Hi, this is Team 15. Our mentor is Kuhu. Our project is Medication Visualizer. This table shows the roles of our different team members and the tools and language we're going to use for our project. So from our prior scan chat, we're going to work on data collection and comprehension and Docker in this week. And we're going to focus on 5 use cases. For example, the patient's identification check, package medicines, etc. And after talking with our mentor, we slightly altered our use cases. So we're going to focus more on the data collection and comprehension at this point. And we're also going to thinking about the app view component design to better understand the data. So our plan for the next few weeks, we're going to focus on the Docker application and will be due this weekend. And for data collection and comprehension is ongoing. So we add like more cases after discussing with our mentors, and we also want to um, alter the app view component according to the data availability in the dataset.
Thanks to Kuhu, after our conversation, we got new ideas for the use case in a more aggregate and medication-based direction. So based on these three use cases, we draw the prototype using Markflow. So in the first case, we allow pharmacists to search a medication name and will show all the medications used for the same disease and same symptom or with the same compositions. At the very right columns here, we'll present the usage trend over time using line chart for each medication. If the pharmacist would like to compare multiple choice in more detail, they can check this medication and click Compare. By selecting several medication options, we extend Kuku's idea and present a table to summarize the relevant information such as price, stock, inclination to addiction, usage method, side effect, allergy, and spatial warning, such as potential risk of other disease. So pharmacists can better compare between these options as well as cater to patients' spatial needs. Finally, they can put their choice in the cart. For From management's perspective, pharmacists might have to monitor the stock of medications. So we show the trend of top-end medications used and any abnormal surge in medication needs countrywide and in the hospital in a period of time. So the pharmacist can predict demand and supply to prepare for stock. Additional advantage would be that maybe pharmacists could uncover abnormal changes in disease development and report to CDC to help find out public health issues.
About the architecture for our application. The framework we are going to use is Django, as this Python framework is fast and efficient compared to Flask. We will run two processes in the backend, the web server and the databases. We will collect the public data about the patient and the drugs from the internet using RESTful API and store this information into our databases. We will also run a server which actively listening for a request from the user, both from the mobile and the website clients. For example, when a user is visiting our website and click a medication, this click event will make a GET request to our server with a URI specifying the medication ID he is interested in. When our, when, when our server receives this request for the medication, it will make a database queries and use the data from the databases to construct the response for this request and send the response back to the server. The response will now have all the information about the requested medicational data the user is interested in. It will also contain a HTTP request code 200. This data code can indicate the request has succeeded. Therefore, when the client finally receives the response from the server about this request, it can use all the information to create and render the views so that the user can finally see.
Hello, so now I'm going to report the status for our deployment. So after reading the given slides, we understand that we only need to manage 3 files, which is the drone.yaml, values.yaml, and Docker file. So for values.yaml, it's a file for deployment, defining how we should deploy containers with Kubernetes. And drone.yaml is a file to define our deployment pipeline. So for example, we may have the testing stage, the staging, and the real deployment in our pipeline. And the Docker file defines how we should containerize our application. So we may want to containerize our front-end app, which we may be able to deploy the app anywhere with the same environment. Next, we're going to show how we deploy our app with various methods. So the first one is the local deployment. So simply running npm start starts the server. So let's just start a server at port 8000. Now let's visit the the website to verify. So we're on port 8000 and let's check for patient ID 100. That should bring up the patient conditions. Next, we're going to deploy with Docker with a simple mock application. First, we have to write our Docker file. So I already wrote one. So Docker file, we specify the environment. So now we specify Gradle. We want Gradle 4.2.1. And next, we define some comments after we set up the container. So I specify the comments I want to run, and finally I said I want to expose the container port to my local port 9025. So let's bring up the containers with the command docker compose. Okay, so that should bring up my containers. Yep. So as mentioned, it should run on port 9025. Yep, let's refresh it. Yep, it's working. Finally, we're going to deploy the app with Kubernetes. So we use Minikube to help our deployment. First, we have to set up the environment with Minikube. Okay, so the command takes a while to run, so I already ran the command. So first, we use the command minikube start Kubernetes to bring up a Kubernetes environment. Then we have to define our values.yaml script. So in the script, I specify that we want to deploy a mock backend using this image with incoming path new test backend. Now we have to run the script provided by the TA. Again, it takes a while to run, so I already ran the script. So it deploys some containers, which contains my mock backend app. Then we run minikube service this to find which URL it is running on. So let's visit this URL. Now we have to append our incoming path. So here we see our mock app.
Per our meeting last Wednesday, we used Mimic as a starting point. The medication resources with corresponding Rx norm code can be queried, and there are many other information included, such as IDs and display names. As to the next step, some medication records contain ingredient information. This can be used for the dispense use case from the previous slide. The ingredient info can also be used as a reference for medication allergies as well, which is mentioned during the meeting. For the administration use case, the information such as inventory and usage trend are not available in the bundle. So I'm currently trying to find a way to collect data for these cases and the use cases are subject to change in the future depending on the availability.